On July 1st, 2025, a NASA-funded telescope in Chile picked up something extraordinary, an object moving through our solar system at over 245,000 kilometers per hour. It wasn't from here. This became the third confirmed interstellar visitor in human history, and from the first moment, it behaved like nothing seen before. Scientists estimate it could be 7 billion years old, carrying chemical signatures no natural comet should have, and traveling on a trajectory with just a 0.2% chance of occurring naturally. What began as a detection quickly spiraled into one of the most mysterious astronomical events of our generation. On the day Atlas was first captured by the Asteroid Terrestrial Impact Last Alert System in Rio Hurtado, astronomers noticed details that immediately raised alarms. This wasn't a typical comet sweeping in from deep space. Its path hugged Earth's orbital plane with almost unnatural precision. Its early spectroscopic readings showed industrial-grade nickel alloys, and the object was accelerating in a way gravity alone could not explain. When it reached perihelion on October 29th, at just 203 million kilometers from the Sun, something happened, something still being analyzed by NASA, ESA, and Harvard's Avi Loeb. He has identified 10 anomalies that challenge everything we assume about cosmic objects. Before diving into those anomalies, understand why 3I Atlas is unprecedented. The object was detected nearly 420 million miles from the Sun, already exhibiting cometary activity at distances where natural comets stay dormant. Archival images showed it was visible as early as June 14th, but overlooked due to its location in front of the dense galactic center. Then, NASA's tests confirmed Atlas might have been active 2 months before its official discovery. At almost 1 billion kilometers out, no natural comet has shown such behavior. Its orbital eccentricity stunned everyone. 6.137. Typical interstellar visitors like Oumuamua are barely above 1. Borisov was around 3.4, but Atlas moves on an almost straight line, reaching speeds up to 68 kilometers per second near perihelion. At discovery, it was flying at 61 kilometers per second. Numbers like these quickly made clear this was not a typical interstellar rock. Now we reach the first anomaly, one that places 3I Atlas at rank 4 on the new Loeb scale for potential technological origin. Anomaly 1. Trajectory alignment with the ecliptic plane. Its retrograde path is aligned to within 5 degrees of the plane where all planets orbit. The odds of a random interstellar object arriving on this exact corridor are 0.2%. It's like hitting a bullseye from across a city. NASA publicly labels this coincidence, but the statistics say otherwise. Anomaly 2. Impossible size and mass. Hubble observations revealed a nucleus likely larger than 5 kilometers, and possibly up to 20. That means at least 33 billion tons of material, over 1 million times more massive than Oumuamua. According to UCLA's David Jewett, encountering an object this massive from another star system should be almost impossible. Yet here it is, and it's moving extremely fast. Combining size, speed, and hyperbolic energy puts Atlas in a category that makes planetary scientists uneasy. Anomaly 3. The forward-pointing jet. Between July and August, Hubble captured a sunward jet, an anti-tail, stretching in the direction of the Sun instead of away from it. Comet dust should be pushed outward by solar radiation, never inward. Loeb stressed this wasn't a geometric illusion. The jet formed a teardrop-shaped cocoon around the object, representing a physical behavior never seen in solar system comets. Imagine smoke blowing toward a fire rather than away from it. Anomaly. 4. Industrial-grade chemical composition. NASA's SPHEREx mission and the James Webb Space Telescope detected a bizarre mixture: 87% carbon dioxide, 9% carbon monoxide, and only 4% water, nearly the opposite of natural comet chemistry. Even stranger was the extreme nickel-to-iron ratio, resembling engineered alloys. Researchers also identified nickel tetracarbonyl, a compound common in industrial refining but almost absent in nature. NASA planetary scientist Emily Saunders called it a monument once in a lifetime, hinting at clues from a planetary system older than ours. Anomaly 5. Extreme negative polarization. Atlas reflected sunlight with a polarimetric signature never documented before. Instead of patterns typical of icy or dusty comet surfaces, its inversion angle suggested something far more complex, possibly metallic or engineered. Loeb emphasized that if Atlas were natural, its polarization would resemble known comets. Instead, it stands alone as the first object of its class. Anomaly 6. Fine-tuned planetary flybys. Atlas passed within tens of millions of kilometers of Mars on October 3rd, approached Venus later the same month, and will come near Jupiter in March 2026. And during its closest solar approach, it was perfectly hidden from Earth due to solar glare. Statistical models place the odds of this multi-encounter path occurring naturally at 0.005%. NASA insists it's still just a comet, but the numbers raise difficult questions. Anomaly 7. Alignment with the WOW signal. In 1977, the Big Ear telescope detected a 72-second radio burst from deep space, the famous WOW signal. 3I Atlas arrived from a region within 9 degrees of that signal's origin. Loeb asks openly whether the two could be related. It may be coincidence, but it's a coincidence astronomers are struggling to dismiss. Anomaly 8. Unprecedented brightening and turning bluer than the sun. Near perihelion, Atlas brightened faster than any known comet. Even more shocking, it appeared bluer than the sun. Natural comet dust reddens light. To turn blue suggests highly unusual particles or an internal energy source. Loeb suggests the color shift could reflect some form of energy emission or propulsion. Anomaly 9. Non-gravitational acceleration without mass loss. JPL detected forces on Atlas that cannot be explained by gravity alone. Calculations show it would require losing at least 13% of its mass, over 4 billion tons. But post-perihelion images show no debris, no extended tail, and no fragmentation. Chilean observatories reported a compact, stable coma, almost identical to Hubble's July image. If mass loss occurred, where is the evidence? Anomaly 10. The missing tail. After experiencing 770 watts per square meter of solar heating at perihelion, Atlas should have erupted without gassing. Instead, it remained intact, displaying only a faint haze. Amateur astronomer Dario Villalon documented that Comet Lemon, photographed the same day, showed a proper tail. Atlas appeared as a round, fuzzy sphere. Loeb argues that if the object is natural and weakly bound, it should have fractured. If it's technological, it may resist heating or deploy mechanisms we do not yet understand. NASA states 3I Atlas poses no threat to Earth and will remain nearly 270 million kilometers away. Tom Statler repeatedly tells the public, it's a comet, plain and simple. But Avi Loeb insists that the data doesn't fit our expectations. He isn't declaring it alien technology. He's urging the scientific community not to prematurely dismiss what could be a historic discovery. Every interstellar object has surprised researchers. Oumuamua was dry, Borisov was carbon monoxide rich, and now Atlas shows extreme CO2 dominance and exotic nickel chemistry. The implications are profound, regardless of outcome. If Atlas is natural, it's a time capsule, perhaps 11 billion years old. It formed when the universe was just 2 billion years into its life cycle. Studying it gives us a glimpse into planetary formation in ancient star systems entirely unlike our own. Its mixture of water, carbon dioxide, carbon monoxide, and potential industrial-like nickel compounds might reveal chemical diversity far beyond our theories. But if Atlas is technological, even partially, the implications are unimaginable. Humanity's most powerful spacecraft, Starship, is insignificant beside a 5 to 20 kilometer object. Loeb calls such an encounter a black swan event, unlikely, unexpected, but capable of reshaping human history. Skepticism has often slowed scientific advancement. Galileo, Einstein, and even modern intelligence agencies have faced backlash for challenging established models. Loeb argues that ignoring data simply because it contradicts expectations is the least scientific approach of all. Atlas passed behind the Sun from late October, hiding from Earth-based telescopes. During its Mars-adjacent pass, ESA's ExoMars Trace Gas Orbiter and Mars Express captured data that may reveal more about the object's structure. ESA's JUICE mission will observe Atlas in November 2025 after perihelion, when the comet should be most active, if it behaves like a natural comet at all. NASA has mobilized the International Asteroid Alert Network and created a new task force to investigate whether Atlas's anomalies arise from natural physics or an unknown mechanism. Atlas will make its closest approach to Earth on December 19th, at roughly 170 million miles, then pass by Jupiter in March 2026 before exiting the solar system permanently. Observers expect it to reappear for ground-based tracking by mid-November as it moves through Virgo and Leo, though its brightness will gradually fade. So what do you think? Is 3i Atlas a natural traveler, a fragment of a forgotten star system, or a technological messenger crossing cosmic distances? Could this be the most misunderstood comet in history, or something far beyond what we've imagined? Share your theories below, and if you want to follow this story until its closest approach, subscribe to the channel. December 19th could be the most important moment in modern astronomy. Will NASA release the high-resolution Mars images? Will radio telescopes pick up anything unusual? And will we finally learn what 3i Atlas really is? Stay tuned.